Hi there and welcome. I'm Rebecca Weaver. I'm going to be solving rational equations today. First up, we need to know what a rational equation is, and it is two rational expressions connected by an equal to sign. So if I have these two, and think of rational expressions basically as fractions. So if I have 1 over x plus 3 equal to 4 over 2x, I need to know what can x be so that this will be true. Well, I like rational equations and they look really hard. They're always so intimidating looking, but you're going to do this little trick that's going to make them so that they're not fractions anymore. What I'm going to do is I'm going to multiply both sides by the common denominator. In this case, it's the 2x over 1 times the x plus 3 over 1. So that's the common denominator. Notice I'm going to multiply both sides by this same thing. When I do, let's look at what happens. I'll have a 2x, an x plus 3, a 1, all over x plus 3. On the right-hand side, I'll have a 4 times a 2x times an x plus 3, all over 2x. Notice that your x plus 3's cancel on the left, your 2x's cancel on the right, leaving you with 2x equals 4x plus 3. Now this is much sweeter and it's much prettier than that original equation that I had. So let's just solve this bad boy. I'm going to distribute the 4. That'll be 2x equals 4x plus 12. I'm going to then move the 4x over to the other side by subtracting 4x from both sides. I'll have minus 2x equals 12. I'll divide both sides by a negative 2, and I have that x is negative 6. Now you're not done. You've got to check these equations because sometimes you have extraneous results, which means you have fake answers. Fake answers can happen with these. So we've got to check this. Of course, I'm going to have one in my slide where we do have a fake answer, so it's coming up. Not this one, though. This one will work. So what I'm going to do is I'm going to check it. X equals negative 6. Take my original, plug in a negative 6. I want to know, does this work? I do the computation. I end up with 1 over negative 3 equals 4 over negative 12. This is negative 1/3 equals negative 1/3. Oh yeah, that works. So you know what I can do? Circle that thing. Easy answer. All right, let's move on. We have some rational equations we're going to solve. Here's our first one. So I look at what I'm going to multiply both sides by. I've got an x and I got a 4. Nothing in common. Multiply both sides by 4x. And I got to make sure that I distribute that 4x. That's one of the most common mistakes I'm going to see. So be real careful about this. You've got to distribute that 4x to both. There's a plus sign there. So I'm going to have 4x over x plus 20x over 4 equals 24x over x. My x's cancel. My 4 cancels. That gives me a 5 there. My x's cancel here. It's the whole reason why we did it. What you have left over after all of your canceling is 4 plus 5x equals 24. Subtracting 4 from both sides, 5x equals 20. And then x is 4 when you divide both sides by 5. You guessed it, I got to check. Fake answers. So here we have x equal 4. We take our original, which was 1 over x plus 5 over 4 equals 6 over x. Substitute in that 4 wherever there's an x. Does this work? Do our computation. I get 6 over 4 equals 6 over 4. Oh yeah, that works. You know what I get to do? Circle that bad boy. X equal 4 is your answer. All right, so let's solve some rational equations. We got some stuff going on here. I have 21 over x squared minus 4 plus 3x over x minus 2 equals negative 6 over x plus 2. Let's factor that first thing. All right, I factored that first term. That factors into x plus 2, x minus 2. So I look to see what I need as a common denominator. You know what it's going to be? I need an x plus 2 and I need an x minus 2. That's really sweet. I'm going to multiply it times both sides. Then I got to make sure that I know that I need to distribute this everywhere. I need to give myself a lot of room because this thing is messy. Now when I distribute with the first term, I multiply this x plus 2 times x minus 2 times that first term. Everything cancels, leaving me with a 21. For that second guy, the x minus 2's cancel, leaving me with 3x times x plus 2. In the very last term, the x plus 2's cancel, leaving me with negative 6 times x minus 2. Now I'm going to simplify, distributing my 3x and my negative 6. I'm going to pull everything all over to one side, and then I'm going to combine like terms. I end up with 3x squared plus 12x plus 9 equals 0. Now, got to factor. I'm going to pull the 3, make it easier to factor. Factors into 3 times x plus 1, x plus 3. That means x is either negative 1 or x is negative 3. That means I have to check 2 things, and this is messy. You see why this thing was like squished all over to one side. So I take my original, plug in a negative 1, do my computation. I end up with negative 7 plus 1 equals negative 6 over 1. Yeah, that works. Negative 6 is negative 6. I can circle that x equal negative 1. He's an answer. Let's plug in the negative 3. Wherever there's an x, I'm going to plug in a negative 3. Doing that computation, I end up with 30 over 5 equals 6 over 1. Oh yeah, that works too. Circle that bad boy. All right, let's try another one. Oops, there we go. We have x plus 11 over x squared minus 5x plus 4 equals 5 over x minus 4 minus 3 over x minus 1. These are so messy. All right, let's write this down again, doing our factoring. There it is. That denominator in that first term factored into x minus 4 times x minus 1. Look to see what would be a common denominator. What do I need? Well, I need an x minus 4 and I need an x minus 1. I'm going to do it to both sides. Then I've got to make sure that I remember to distribute it to everything. All right, so let's do our distributing. In our very first term, the denominator cancels out, leaving me with x plus 11. Next, we have a 5 over x minus 4. Those x minus 4's are going to cancel, leaving me with 5 times x minus 1. Watch that sign. That's a minus sign. Be sure to put him in. Then I have 3 times the x minus 1's cancel, leaving me with x minus 4. I'm going to distribute, being very careful to watch my signs, move everything over to one side. I end up with negative x plus 4 equals 0. When I move things over, this gives me that x is 4. I need to check it. So let's take our x equal 4, plug it in to our original. Wherever there's an x, I'll put a 4. Then I'll do my computation, and what do I get? 15 over 0. What? That's undefined. Equals 5 over 0? Minus 3, no. 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 You are not an answer, you silly little thing. This one has no solution, because if it had a solution, it would be x equal 4. Since x equal 4 doesn't work, no solution is your answer. All right, if you have any questions, be sure and email me, rweaver10@alaska.edu. Have a fantastic day. Bye now.